Now theorem 5. To now from here onwards, 5th onwards, we can also say elementary properties of the Boolean algebra. Okay. So it is involution law. It is inverse of A and its inverse, that is A. Okay. In the set theory also we have done same thing, A's complement and whole's complement, or you can say complement of A's complement is A. Same thing is here. Okay. So let us prove it now. To prove inverse of A inverse, that is what? That is A. Now proof. By the definition of inverse, or you can say complement. By the definition of inverse or complement, what we are having? A plus A inverse is equal to 1 and A dot A inverse is equal to 0. Let this be 1. So can we write it like this? A inverse plus A is equal to 1 and A inverse dot A is equal to 0. So what this is? Commutative property. Okay. Now let us suppose that, now let A inverse is equal to B, then inverse of A inverse is equal to B inverse. Okay. Now again we are having B plus B inverse is equal to 1 and B dot B inverse is equal to 0. By definition of inverse. Okay. So now just putting the values of this part in the first equation. Okay. So what we are having now, we can write it A inverse, because B is equal to A inverse. So A inverse plus, now B inverse is what? A inverse is equal to 1 and A inverse dot inverse of A inverse is equal to 0, 2. Okay. Now comparing, one and 2, we get inverse of A inverse is equal to A. Hence proved.